For this on-demand and virtual workshop, we will be building out an actual hands-on Azure Data Lakehouse that you can replicate in your own environment. Before we start, I just wanted to review a few things to make sure that expectations were set clearly. This is intended to be a quick and hands-on introduction to Azure Data Lakehouse architecture. It's not intended to be a comprehensive explanation of everything that you can do with an Azure Data Lakehouse. It's also not intended to be a demonstration of best practices for working in Azure Data Factory or for how you should set up the bronze, silver, and gold layers of your Azure Data Lakehouse. In fact, there's a lot of things in here that could have been done more efficiently, or where the introduction of other tools could have made it faster or more efficient or more scalable, but that wasn't the point of doing this. The point is that you can walk away from this understanding what the architecture is and why there's value in using it. And thirdly, Azure Data Factory was chosen as the primary tool because it's affordable and accessible for a low-code workshop. Azure Data Lakehouse is an architectural pattern. It's not a set of tools. So there are other tools that you can and often will use in the real world when working with an Azure Data Lakehouse architecture. Welcome to the virtual workshop for Azure Data Lakehouse in an hour. My name is Greg Beaumont. I'm the creator and presenter of this workshop, and I'm a senior cloud solution architect at Microsoft. The term data lakehouse is all over the tech industry these days, and when I first heard it, I thought it must be extremely complicated and difficult to learn. Once I started learning about it, I realized it makes a lot of sense, and if you have a data warehousing background, it makes even more sense. So I thought there might be some value in putting together a quick tutorial where you actually build out a data lakehouse using a reference video that's less than an hour long. So yes, we will actually build out a data lakehouse end-to-end in this video today, and I'll do it within an hour of time. If you want to have a hands-on experience, everything in this video can be replicated in your own Azure subscription. It might take a little bit more than an hour, but you can just replay some of these chapters within this video, which are linked in the description below, in order to replicate everything in your own environment. Then at the end of this workshop, you'll have built a data lakehouse in Azure with real CDC data. The data will be updated every week, and you can build upon it as you continue to learn new things in the future. I think by watching this video, you'll be able to walk away understanding what a data lakehouse is and why there's value in considering it. So who's this workshop intended to benefit or target? Basically data architects, developers, and engineers, business intelligence professionals who want to expand their skills, data scientists who are looking to explore new ways to house a scalable infrastructure for data that they work with, and also anybody who's just looking to become a data professional. So what do you need to do this workshop? Well, all you really need is an Azure subscription. And if you don't have one available from your employer, you can get a trial subscription at the link that's listed here. You'll also need to make sure that you can deploy an Azure Data Factory and an Azure Data Lake Gen 2. The first steps of the video will actually show you how to do that. You'll also need to make sure you can access an HTTP endpoint from Data Factory in order to pull in all the data. So what data are we using for this workshop? It is the CDC National Notifiable Diseases Surveillance System. It basically tracks dangerous diseases and how many cases there are at a geographical level over time on a weekly basis. I chose it because it's a single table of data, so we can get it done, hopefully in less than an hour. But there are some complexities with the granularity of the data. The data does change over time, and there are some transformations needed in order to get optimal performance when you're reporting on it. Then I'm also pulling in a date table from my GitHub repository, just to be able to show how you can link different tables of data from different places together, and how that might look inside of a data lakehouse architecture. I want to be clear that the workshop is not going to draw any conclusions on how you should use the CDC data. I chose it because it's an interesting data set that you might want to explore on your own after building this in order to draw your own conclusions, and because the architecture of the data makes for a good, short, concise workshop. So what's different about Azure Data Lakehouse from, say, a traditional data warehousing setup? So with the Data Lakehouse, you can pull different types of data, whether it's structured data like we're used to from relational databases, whether it's unstructured data, and also semi-structured data. Effectively, you will extract that data from the source, then make a carbon copy of it in the bronze layer. Then in the silver layer, you'll start adding some metadata, cleaning it up, getting it ready to report on. And then the gold layer will be optimized for fast queries and performance when using it for reporting purposes. Now, I should note that a data lakehouse is an architectural pattern. It's not actually a tool in Azure. So you're building it within an Azure Data Lake, but you can use different types of tools for the ELT, for the compute layer that goes on top of the data lake, for query caching, for the business logic that goes into different types of solutions. Effectively, this is a way to store limitless amounts of data inside of an architecture that's flexible, and it's also future-proofed so that different teams can use different tools to access and make use of the data in a way that will hopefully also optimize costs. So analysts and developers, data scientists, and data engineers, they all might want to do very different things with that data and use different tools, and they can use their own tools that have dedicated compute, logic, and query caching in order to make that happen. So I should note too that those different users might want to use different layers of the data lakehouse. For example, front-end business analysts might want to go straight to the gold layer where the data is perfectly curated and ready to go, so they don't have to clean it up or do any type of cleanup before having the reporting ready to go. Whereas data scientists, they might want those raw files where they can look at the CSV and pull out little details that other people didn't care about, but that actually have meaning when you're looking at it from their perspective. They might also just want to go straight to the silver layer where things are slightly curated and it makes it easier for them to build machine learning models. Then your data engineers and architects will be looking to do things at scale in order to move data around efficiently and get it ready for everybody in the organization to make use of. So for this particular data set, what are we effectively doing during this workshop? We're pulling in both the CDC data and the date data, writing it to the bronze layer, adding some key values and some metadata at the silver layer, and then creating some optimized tables for reporting at the gold layer. All right, so let's start building an Azure Data Lakehouse. Step one, we're going to create the resource group, an Azure Data Lake, and an Azure Data Factory. Here I am in my landing page for a brand new Azure account that I created with a personal account. If you start a new account for this workshop, it'll probably look something like this. Let's go to Resource Groups. You'll see there's nothing here yet, so hit Create. We'll go ahead and name this Lakehouse in a Day, and we'll leave it in US East. And let's go ahead and create. Now that we have a resource group, let's go ahead and click on it. And within that resource group, let's add a data lake. Hit Create, add the storage account. Let's give it a name. Leave it in East. We'll do a standard since this is just a quick workshop. And with redundancy, we'll just do locally redundant. Again, this is just a POC workshop. Data protection. Let's get rid of the soft deletes. We just don't need this due to the scope of what we're trying to accomplish. Move to Review and Create, and let's create. Once it's been created, you'll see a message that your deployment is complete. Let's go back to the resource group and just validate that it shows up. Now let's quickly go to that storage account, take a quick look at blob service, and let's create a container. Call it Lakehouse in a Day. Hit Create. And then we have a container in our data lake. Moving back to the resource group, now we will add a data factory. And let's go ahead and create. Call it Lakehouse in a Day. Leave it in East and V2. Again, this is a quick workshop, so we'll configure Get later. That's if you even want to keep this when you're done. And let's review and create. And validation passed, we'll hit Create. And deployment complete. Let's go back to the resource group. And you'll see that we now have a storage account and a data factory sitting inside of that resource group. Moving on to step number 2, rapid prototype of the data model. The data that we'll be using for this example is the National Notifiable Diseases Surveillance System weekly data from the CDC. So if we move down here at the CDC site, you'll see we have a link to information about that data. Let's go ahead and browse it. And here you can see some information about the data set, including the columns that are in that data set. You can actually take a look at the data and browse some of the actual rows. And here you can see it's at the level of year and week, and label is going to be the disease that is being tracked. And then you also have some location information and some geocoding information, which looks like latitude and longitude. We'll keep this brief in order to stay within the confines of a short workshop, but there's many different ways to do rapid prototyping of data like this. Personally, I like to use Power BI, so let's take a quick look at this data and see if we can get some more insights about how we're going to want to design the data model after we get this data into Azure. So again, without spending too much time, I'll just review some of the findings that I was able to uncover by pulling this data into Power BI and browsing the data in its raw form. So you can see here that I've filtered for just the first 5 weeks of the year 2022. The first thing that I noticed is that location 1 and location 2 are populated a little bit differently. And after digging into it a little bit, it looks like location 2 is actually some sort of aggregation where you have different regions of the country. There's also a total, US territories. Whereas when location 1 is populated, it's effectively states of the United States. And when you have that state, then you also get a latitude and longitude that is associated with that state. So first things first, we'll want to split that latitude and longitude into 2 separate columns so that it's easier to work with for end users. We'll probably leave this column as it is and then add a latitude and longitude at the silver layer. And then at the gold layer, just make sure everything is optimized. There's also a column here called reporting area where whichever one is not blank is the one that gets populated. What we'll do for the workshop is leave this table as is for the silver layer so that you have a cleaned up version of this source table at that silver layer. Then at the gold layer, split it into 2 separate tables, one that has these aggregations and the other that has the state level data. The reason being is that otherwise you might be double counting. So some of these aggregated values contain aggregates for different states down here. So summing up all of these columns is not going to give you the actual number of total cases over that 5-week period. It's going to give you something different. Again, because this is a workshop focusing on the data lakehouse architecture, we're going to stop with that gold layer. Interpreting how you actually want to report on this data is going to be up to you. And I actually think it would make a great workshop because there's some granularity differences within the table itself. If you notice here, for example, if you look at what the cumulative value should be for 2022 through week 5, and then you compare it to the actual, there's some differences there. If we go back to the data definitions and expand more, you'll actually see there's a PDF document explaining what all of those differences are and how they can be interpreted. So for example, here it's showing how discrepancies in reporting get remediated week over week. This isn't going to impact what we're doing in the workshop, but if you're going to build front-end reports on this data, this is a document you should probably review very carefully. So in summary, looking at this data, we'll create a key value for the week so we can tie it to other data from a date context over time. We'll clean up that geocode data, and in the gold layer, we'll also make 2 separate tables, one for the aggregate values and one for the state values. Step number 3, defining the data sets for the Azure Data Factory. Based upon the rapid prototyping that we just walked through, here's a diagram of the different data sets that we'll need to define in Azure Data Factory. The first layer will actually be pulling from the web, and then the subsequent layers will be within the bronze, silver, and gold layers of the Azure Data Lake. From the web, we'll be pulling the CDC data and a date table that I have in a GitHub repository. Both of those are CSV files. A carbon copy of that CDC table will be brought into the bronze layer, and then towards the end of the workshop, we'll set up a weekly pull to keep historical versions of that data as it changes over time. There'll also be a copy of the date table in that bronze layer. All of those will also be CSV files. And some additional transformations will turn that data into Parquet files at the silver layer. There'll be geography tables, tables that contain the counts, along with key values for geography and each week, and then also a Parquet file that will be for the date table. Then finally, at the gold layer, we'll have different files which will allow users to build both the star schema version of this data that can be used to tie the data to other sources of data, and a flat file where everything's been normalized for users that don't want to work with the star schema. And then also a date table in Parquet format will be available there too. We are going to start with defining the sources for the CDC data and also the date table. Moving back to my resource group, I will go to Data Factory, launch the studio. Once in the studio, click here on the authoring button, and we're going to go ahead and define some data sets. So just to describe what we're doing, the data set will point to where an individual artifact or landing zone for artifacts exists. We will then use pipelines to orchestrate how those things get imported and transformed. And once the data is in the lakehouse, if we need to make transformations on it, we can use the data flows to make those changes. So let's go ahead and create a new data set. The first one will be the CDC source, which is on the web. it will be a CSV file. And let's take a quick look at that source. You can see here that there's different ways to go get the data. You can just export it. There's an API. I'm not sure which is going to be the most efficient way to go get it, but since it's such a small amount of data, it doesn't really matter for the workshop. I'm just going to go ahead and copy the link to the CSV. Moving back to the Lakehouse, we will call this, and after giving it a description, define the link service. Here's that URL I copied. It's on the public web, so it's anonymous, and let's hit create. Now, taking a look back at this slide, let's go ahead and add a link to the date table, which is sitting in my GitHub repository. So within my GitHub repository, I have some date and time scripts, and I've put the CSV file for a date table right here, just to make it quick and easy. You can use any source you want for a date table as long as it has the key values that you need to do this. I just chose this as a simple way to do it for the workshop. Now to pull this data in, let's click on the raw button, and then we'll get the link to a version which can be pulled in as a CSV. Let's define another data set. It's also a CSV. Add that URL. Again, it's anonymous, and create. Now, moving to the bronze layer. This is where the data is actually going to land. So we'll want to create one file for the FDA data, and then a landing spot for the weekly snapshots, along with a copy of the date CSV file. New data set. And now we will be landing in the Azure Data Lake Storage Gen 2 that we created. Still be CSVs. And select my storage account. You'll see now we have a link created to that data lake. Hit create. For now, let's select the root folder. Hit OK, hit OK. Now for the file path, there's different ways you can handle this. It's kind of up to you. So you can make the directory be bronze, silver, or gold, or you can have that be a project name and then have bronze, silver, and gold within it. Data Lakehouse is an architectural pattern. It's not something which is set in stone or a product. For this workshop, I'm just going to keep it simple and put bronze, silver, and gold at the directory level. If you disagree with that strategy, just add a comment in the notes and explain. And we will call this the weekly file. Now let's add a snapshot version. And we won't do much with the snapshot version since this is Data Lakehouse in an hour, but that'll give you historical versions of that table that you can get a copy of each week. So if you ever need to see how things change over time, you'll have that history. Let's just go ahead and copy this data set. And instead of copy one, we'll call it snapshots. And I will remove the file name. You may want to put a subfolder or something like that for these snapshots. It's up to you, but for the sake of simplicity, I'm just going to put everything in the bronze layer. And new data set, Data Lake Gen 2, CSV. Add the directory. We'll just call this date. Moving to the silver layer, we'll want to create a couple different Parquet files, one for geography and one for the CDC data, and then also a date Parquet file. I debated just skipping the silver layer for date and moving straight to gold, but for a best practices demonstration, I thought it would be a good idea to have a copy of it in each layer, because we're not really going to do much with it when moving from silver to gold, but it just made sense to do it this way. So we will do new data set, Azure Data Lake, Parquet. Now I should quickly mention the reason we're choosing Parquet for the silver and gold layer is that you can have metadata associated with that file. So you'll know if it's a date field or an integer or a text field, and that eliminates some of the need to redefine all of those things at the next layer up. You can still redefine it if you need to in those layers, but this reduces some of that work and adds some consistency to the data that you're working with. Parquet files also work really well with compute layers such as Spark. And let's keep the naming convention consistent. So we'll do CDC weekly.csv. Now let's go ahead and copy that or clone it. And looks like I made an error here, so bear with me. So we want the Parquet file extension. I'm going to add that here too. And let's also go ahead and clone that one more time to make a date dataset in the silver layer. Now, taking a look at the gold layer, we will have two different Parquet files for geography. One will be at the state level, and the other will be at that aggregate level that we talked about previously. Additionally, we'll have two Parquet files for the base CDC tables. One will be at the state level, and the other will be at that aggregate level. There will also be a separate file in the gold layer, which will be a flattened, denormalized version of the table. So there's no dimensions, no star schema, for folks who just want everything in one big table. And then we'll also have a version of the date table that users can grab from that gold layer. Let's go back to the datasets and let's clone that silver date. Just change it to gold. Clone geography. Call this one state. Clone this one. Call it ag. Clone the weekly. Change the name to gold. And then I want to go back and just make sure that I didn't miss something here. So we want this in the gold layer. And we also want this in the gold layer. Now we can clone this. Just change that to ag. Let's go ahead and clone this one. Call it normalized. Now let's publish everything up. And we've got all of our data sets designed and ready to go. Step number 4, let's populate the bronze layer of the Data Lakehouse. So what we'll be doing in this step is simply just copying over the CDC and the date tables or files into the bronze layer. All right, so we can do this with a pipeline. Let's go ahead and create a new pipeline. We'll call it get date. We are just going to copy data. And the source will be the source date table, which we defined. And the sink will be the bronze date table. Now, one other thing we want to check here. So if we look at the date table, is my date table does have headers. So we'll want to make sure we check that for the data sets. Now let's go ahead and publish. And let's run that pipeline. We'll just trigger it straight from here to populate that bronze layer. You can see that it's in process. And you can refresh to see that it succeeded. Now if we move back to our resource group, check that storage account, go to blob service, choose the container, you'll see we now have a bronze layer, and in that bronze layer is the date table. Let's move back to the author mode, clone that pipeline, and we'll call this get CDC data. The source for this one is source CDC, and the sync is bronze CDC weekly. We'll worry about the snapshots later on in the workshop. Again, the data has headers. Let's publish. And let's run it. We can validate that it made it to the bronze layer. Step number 5, populate the silver layer of the data lakehouse. For this step, we'll take that CDC data and convert it to Parquet files for geography, which will be a dimension table where each row represents a unique geographical mapping, and then also a table of the transactional data. And that transactional data will still contain the geography data because we want to have both star schema and a normalized flat version of the data available in the gold layer to keep everybody happy. Then we'll also pull over that date table. All right, so back here in the authoring view, we will start populating the silver layer by moving the bronze date file to the silver date file. In order to do this, we will use a data flow since we'll make some transformations to the file and turn it into a Parquet format. Let's create a new data flow. The source be the bronze date. Let's double check that bronze date data set and make sure that first of all it has first row's headers checked, and let's also give it a schema. Let's import from the file that's already sitting in that bronze layer, and you can see that the different columns from that date table are being pulled in, and the names are associated with them properly. Moving back to the data flow, we will call this bronze date to silver. We will get the bronze date. Let's check and make sure that the schema is coming in appropriately. As you can see, because it's a CSV, everything's coming in as a string. So we're going to want to assign some metadata to those columns in order to have the Parquet file associate with the data type. So next we will do select. And what select is going to do is once you've gotten that data, it's going to select certain things from that particular CSV file and move it to the next stage of the data flow. So I will fast forward through these changes, but effectively what I'm going to do here, I'm going to eliminate the blank spaces between the names for the Parquet file. Next, I'll do a derived column so that we can assign the data types to those columns of data from the date table. Let's call this again, I'll fast forward through this so you don't have to sit and watch it, but you can still reference all of the different expressions that assign the data types. If you want to, you can open the expression builder in order to find the expression you need to make the transformation to that column. Now you can double check that everything's done correctly. And it looks like I missed week number or week num, so let's go back and fix that. And then if you'd like, you can actually do a preview of what the data will look like by turning on debugging, which uses Spark in the background in order to preview the transformations. So once the debug's ready to go, I'll hit Data Preview and refresh. And it looks like there's no errors, which is good. And you can visually inspect the work that you've done. So we can turn the debug back off. And let's go ahead and add a sink, which is where the data is going to land. So we will call this the Date Silver Sink. We'll land in Date for Silver. For the file name option, we'll output it to the name date.parquet. And we do need to move it to a single partition since we're having only one file as the output. And then we should be able to go ahead and publish. And now let's create a pipeline. Call it Silver Populate Date. Now we're going to be running a data flow, the data flow that we just created. And we're good to go. So let's go ahead and check it in. And then we'll go ahead and trigger it. Let's refresh, and we'll see that we have a successful run. Let's move back to the Data Lakehouse and just validate that we now have a silver layer that has a date table in it. Now we will go ahead and move the weekly CDC data from the bronze layer to the silver layer and clean it up in the process. Taking a look at the bronze data set that we already populated, it does have first row checked as headers, and let's import the schema. Check to make sure that the column names look good, and then we'll go ahead and check that in by publishing it. Now that it's published, let's create a new data flow. And we'll pick that bronze source. And what we'll do next is select the columns in order to clean up the names. Now I'll fast forward this part, but you should see the naming conventions that I used on the right-hand side. Now let's debug and see how everything looks. Okay, now if we go to Data Preview, hit refresh. Let's keep scrolling to the right. And next we're going to focus on the final column here, which is geocode. You'll see that it's a single column that has the word point and then also the longitude and the latitude. So what we're going to want to do is create two new columns, one for the longitude, one for the latitude. To do that, we will separate by the space so that it creates 1, 2, 3 columns. Keep the second two and then drop the opening and closing parentheses. So to do that, let's go ahead and add a derived column. We will call this New Columns. Longitude and latitude. I'll open the expression builder. Now for longitude, I'm pasting this piece of code in, but to show you what I'm doing is I'm saying take the column geocode, split it wherever there's a space, and then replace in the second column that's created from the split the opening parentheses with the blank space. Let's actually just make that nothing. Now we can do the exact same thing for latitude, but we want to take the third column that's created and replace the closing parentheses. While we're at it here, let's add 2 more columns. The first will be created date, so that every single time this particular data flow runs, we'll know what the date was. And that's current date. Then the next is a key value for the year and week. Now for that year week key, let's open the expression builder. And what this is going to do is concatenate the year, which is already a string. And then it's going to have a case statement and say that if you turn the week into an integer and it's greater than or equal to 10, just use the week. Otherwise, put a 0 in front of it. So for example, if we're looking at week 3 of 2022, the result would be 202203. Now, since we still have debug turned on, we can go ahead and take a look at the results. And scrolling over to the right, you'll see that we now have the longitude, the latitude, the created date, and the year week key. Now let's go ahead and assign data types to these columns. As you remember, the Parquet files can contain metadata. I'll move quickly through this part and fast forward it so you don't have to sit and watch it. Now let's check the preview with debug turned on just to make sure that we didn't make any mistakes. And let's scroll to the right. Looks good. So let's turn off debug. And let's add a sync so that we can write that file to the silver layer. Let's go ahead and publish. Create a new pipeline. Publish, and let's trigger it. And once it's succeeded, we can go validate that the file is in the silver layer. And there we go. Moving back to the authoring view, let's go ahead and create a silver data set for geography. To do that, let's go ahead and copy, or rather clone, the CDC data flow for bronze to silver. And then we'll modify this one to be bronze to silver geo. So we're still getting the data from the same place. Then we just want to change what we're going to be selecting. So we will keep reporting area, but not year. Just narrow it down to those 4 columns. And we still want these new columns, but I think we can get rid of the year week key. Let's check the data types. We can get rid of this entire step. Now what we'll want to do is narrow it down to just the distinct versions of those combinations of geography columns. So we'll do an aggregate. And we probably could just do it on reporting area, but just to be safe, let's add some additional criteria. And reporting area is a combination of the two different granularities of geography. So in theory, that should be the unique determinant of what constitutes an individual row. Now to aggregate it by something, we'll just call this the ag and we'll drop it later. And we can just use account here. Now let's turn on the debug and just validate that that looks all right. So let's go to the preview, hit refresh. Okay, and that looks good. Now we can go ahead and turn off debug. Let's give the table a primary key. We'll call it geo key. Let's go back to the get distinct step and add some additional columns. Now let's go back to add key, take a look at the inspection. We don't need the column ag, so let's get rid of that. Drop that one, and then the sync will be the silver geography. Now let's go ahead and publish. Add a new pipeline. And one thing we forgot to do is specify the table name. So here's the table name as defined in the data set. Let's go back to bronze, date to silver. And in the sync, we will specify that table name. Publish, and let's go ahead and trigger it. And once it's succeeded, let's go back, take a look at the data lakehouse, and in the silver layer we now have geography, weekly, and date. Step number 6, populate the gold layer of the data lakehouse. For the gold layer, we'll take the files that were created in the silver layer and we'll optimize them for reporting and analytics. First, we'll create a star schema version of the tables, which will be 2 different geography tables, one at the grain of individual states and the other containing the different aggregation levels that were present in the data. Secondly, we'll create the transaction table. There will also be 2 of those, one for the states and one for the aggregations. That way you'll make sure there won't be any double counting. Thirdly, for teams that don't want to use a star schema or a relational database, we'll create a big flat table that contains all of the data as it existed in the source file. And fourthly, we'll pull over a date table. So back here in Data Factory, we'll start by moving the date table from silver to gold. In order to do that, let's first take a look at the silver date dataset, make sure that it has a schema. And you can see we have that Parquet schema where there's both data types and column names. Let's go ahead and publish that. Now we should be able to take the existing data flow for bronze date to silver, clone it, and change it to silver. Silver date to gold. Get silver, getting from the silver date. We're not going to rename anything, so we can get rid of that column. And we're not going to change the data type, so we can also get rid of that step. And let's go ahead and publish. Now we'll go ahead and run all of these data flows at the very end, since they should be fairly straightforward. Next, we'll move over those geography tables. Or rather, we'll take the single silver geography table and split it into 2. Let's go ahead and look at that silver geography table. import the schema. Let's go ahead and publish. And now let's create a new data flow. Silver geo to gold. Get silver geo. And next we'll go ahead and do a split. And the conditional split will take the data in that table and then split it into two separate tables, one being the state table and the other being the table of aggregations. All right, so let's name stream number 1 states and stream number 2 geoags. And the condition will be if location 2 is null, that means it's an aggregation, not a state, and it will be routed to the secondary stream. If it is null, that means it's a state, and it'll be routed appropriately. And now let's add a sync to each of these. So let's select the dataset, which is the gold CDC geography state. And we want it to write to a single file. Which will be CDC geography state part K. Now let's do the same thing for the ag. And then we can go ahead and publish. Now let's go ahead and clone this. And by cloning it, we can reuse that conditional split. Let's go ahead and rename it. Get the silver CDC file. And I forgot to pull in the schema, so let's go ahead and do that. Back to our data flow. Publish the pending changes. Take a look at our split. Looks good. Rename the LZs. Remap this one to state. Give it the appropriate name. Move to the ag file. Remap it. Rename it. And two things I forgot to do. One is remove the columns that we don't need, and two is add a key value for the geography tables. So now we want to add the key values from the geography table. Let's go ahead and do that before we do the split. So we only have to do one join instead of two. Add geo key, and we'll want to add another source, which is going to be the silver CDC geography. Do a left outer. The join condition will be on reporting area. Then we can select. So let's go ahead and remove the columns we don't need from the join, which are going to be down here, the geo columns. Keep the key, we need that one. And then for the time being, we need to keep the location 2 column because that's what we're using for the conditional split. Once we've done that, we can then remove the location 2 column from each of the separate streams. And our 2-star schema fact tables should be good to go. One will have detail level at the state level of granularity, and one will be at those aggregated fields level. And while we're here, we can go ahead and add a sink for that normalized table of data also. And to do that, we'll just go back to the source and add a sink. Set the destination name. And let's just review. So from the source silver file, we'll make a copy of it, which will be a big normalized Parquet file sitting in the gold layer. Then for the second stream, we'll add the geography key. We'll select the columns that we want to keep from that join. Then we'll break it into two streams, one that contains granularity at the level of state, one that contains granularity at the level of aggregations. Remove the unnecessary join column, and then write to a Parquet file sitting in the gold layer for both the state level aggregations and the aggregated levels. And step number 7, automate the weekly update and store the historical snapshots. We'll start by creating a pipeline for the weekly snapshots. Here you can see we already have the data set for the bronze CDC weekly snapshots. We go back to our diagram. We're now adding this landing zone for those weekly snapshots. And that'll just be there as a historical record of what the file looked like each week when the package runs. So moving back here to Data Factory, we'll open up Add Dynamic Content, and I'll paste in this string of code and just kind of explain what it's doing. It's saying concatenate CDC _ NNDSS _ with the date and time of when the script runs, along with .csv at the end. Hit OK. Let's publish. Now, moving back here to our complete diagram, we'll orchestrate the weekly pipelines that update all of this data. So the date table doesn't change, so we can just run that one once, but then we'll set up the CDC data to run weekly, capture a historical snapshot with the date attached to it, but then replace these other layers with the new data. Let's start with the date. So what we can do here is use our original date pipeline, add a data flow for silver date, which will be bronze date to silver, add another data flow for gold date, which will be silver date to gold, and then we'll also want to go ahead and delete the old versions. So we'll do a delete the bronze date, then we'll go get the new date from the source, then we will delete the silver date, and one more delete. Let's organize all of these, and we probably want to say do not log. You can log all of your actions if you want to in a more complicated build. And there we go. What this will do is delete what's in the bronze layer, repopulate it, delete what's in the silver layer, repopulate it, and then delete what's in the gold layer and repopulate it. Let's go ahead and publish. And then let's go ahead and run it just to validate that it actually works. Let's hit refresh, and it looks like it succeeded. Quick note on that final move from silver to gold, I probably didn't need to create another data flow. I could have just done a copy data and it would have been a little bit more efficient. The reason being is that no changes were actually made to the table. Now let's go back to the authoring mode, and at this point the get date is doing everything that we need to do for the date table. So we can get rid of this pipeline. It's no longer needed. And now let's use this pipeline to build out all of the other data orchestration and ELT. So before we get the data from the source, we will want to delete the bronze CDC weekly table. We don't need to log. Now let's go ahead and copy that action. And this will be for the weekly snapshot. So this does not get deleted. The source is the same. but then the sink is the bronze snapshots. So every time this package runs, a snapshot with the date appended to the end of the name of the file will be added to the bronze layer. So looking back at our slide, we're taking that source CDC data file, we're deleting the snapshot, replacing it with a new one, and then writing a historical version right here. So next we need to delete the geography silver layer, delete the CDC silver layer, and then replace both of those. So let's add another delete for the silver geo. Let's add a delete for the silver CDC. Then we'll add a data flow to populate the silver CDC. Add another. Populate silver geo. Moving back to our diagram, we've now replaced everything in the silver layer with the daily update, and now we need to delete and replace everything in the gold layer. So first we will delete the gold CDC ag. Next, the gold CDC weekly state. Add weekly up here just for clarity. Next, the normalized table. Next, the aggregated geography table. And finally, delete gold geo state. Now, we'll want each of these data flows to finish before the next deletes kick off, just in case something fails. And then each of these can be repopulated once the existing is deleted. And if you remember, the silver CDC to gold actually populates both of these tables, so we'll want both of those to finish being deleted before running the pipeline. Actually make that 3, because it also populates the normalized table. geography tables. And then at this point, we'll be populating both geography tables in the gold layer, along with the normalized table, the aggregated fact table, and the state level fact table. And moving back, you can see the dependencies of all the different deletes and data flows that happen with that daily update. So let's go ahead and publish. And one other thing we can do here too, just to clean things up, is we can get rid of these other pipelines that we no longer need. So nice, clean, and simple. We're down to 2 pipelines. If we zoom out, we get a nice, clean view of the entire process. So now let's go ahead and trigger it and make sure it runs. Now, while it's running, we can actually click on the pipeline name and take a look at where everything is at. So right now we're at populate the silver layers, and the previous layers have successfully been populated. Once the pipeline is succeeded, you can actually click on it and then take a look at all the different steps that happened and succeeded, along with how long each of those different steps took. Let's go back to the data lake. Take a look at the bronze layer. You'll see we have the weekly data, the date data, and then also the weekly snapshot. Let's go up, check out the silver layer. We have the geography table, the weekly table, and the date table, and all 3 are Parquet files. And then the gold layer. We have the geography table at the aggregated level. We have the geography table at the state level. We have the weekly transaction table at the aggregated level to tie to the geography table. We have the weekly normalized table, which just has everything in it for tools that don't like relational databases. Then we also have the transactional weekly data at the state level, which will tie to the geography state table, and a copy of the date table. And all of these are Parquets, so they have metadata such as data types already assigned to them. So back here in the authoring view, I'm looking at the Get CDC Data pipeline, and this is the one that we want to schedule to run weekly. You can see I already set up the trigger. I did it a couple of days ago just to verify that everything works. But you could hit New and then set up what I'm about to show you. We'll go ahead and edit the existing trigger that I already built. So you can see this is a pretty simple interface. You just give it a name, what date you want the process to start on, if you want to specify by time zone, how often you want the recurrence to be. Because this is weekly data, I set up the run to go once a week, and I set it up on Tuesday, so I arbitrarily chose Wednesday at 3 a.m. to do my weekly run. And then once I saved it, the run will happen once a week. So if I move back to monitor, you'll see that it did run on Wednesday at 3 a.m., took a little over 10 minutes, and everything succeeded. If we go back to the data lake and take a look at the files, you'll see in the bronze layer, we now have a snapshot for the original run, a snapshot from Wednesday, along with a new version of the weekly table. Again, in a production setting, you'd probably want a separate folder for all of these snapshots, but this is just a simple workshop. Looking at the silver layer, everything updated for the 18th except for date. And likewise in the gold layer, we now have all of our newest and freshest data available for update with whatever applications or tools are querying those Parquet files. Now looking at the resource group here, I'm actually filming this after I've completed all of the other components of this workshop. And I just wanted to review what the cost was for me to actually build this out, record everything, and implement a weekly run. So if I go to cost analysis, you'll see that I started building this out in early May. And over the course of the entire project, it ran up a bill of about $5.50. The vast majority of that was the data factory work, and the storage was about 50 cents. Again, this is going to change depending on what region you're running things in, how many times you run things as you're testing them. But I just wanted to show that this is not a very expensive workshop to implement. And at the end of it, if you decide to, you can delete the whole thing and you'll never incur any additional charges on the work that you've done. So to close things out, what have we built? We've effectively built a data lakehouse architecture in Azure Data Lake using Azure Data Factory, where we pull in CDC data, clean it up, organize it, and then optimize it for different types of reporting at the gold layer, along with a separate date table that we can use in order to do different types of query and filter criteria. If we were to just simply look within that gold layer of how things relate to each other, you'll see that we have both a star schema for tools that need optimized query performance, and also a big normalized flat table for tools that don't work well with relational databases. Please provide any feedback in the comments below. I do plan on turning this into a Azure Data Lakehouse in a day course or workshop, so anything I can do to make it better that you can think of would be greatly appreciated as feedback.